Number 10 is another problem where we have to verify the identity. This is going to be coming from the section that talks about double angle and half angle formulas. So as far as the test is concerned, if you take a look at number 10, both of them have a double angle in there only, and so that's the only identities you'll have to know. So even though the whole section had double angles and half angles, you only need to be responsible for the double angles for this problem. So the one that's in the actual final will be one that has a double angle that's in it. Now, we can start with either side. Now, we can work with that one. Secant is the same thing as 1 over cosine. So I'm going to change this into a 1 over cosine 2 theta. And then this, I'm going to change all those into 1 over cosine as well. So that's one of the first strategies that we have with verifying the identity, is you look for, if you can change everything into sines and cosines, you want to do that. So I will do that for this one. So 1 over secant, that's 1 over cosine squared. Because there's a square there, there'll be a square in the formula. Likewise, the same thing will happen down below. You have 1 over cosine squared, 1 over cosine squared theta for top and bottom. Another strategy that we talked about is getting common denominators. We want to get common denominators so that way we can get rid of the fraction over a fraction situation that's happening on this problem. So the left-hand side I'm going to leave alone. Now I know that there's identities that I could put in for cosine 2 theta, but because there's 3 of them, I wouldn't know which one to put in at this step. So instead I'm just going to leave it alone. I'm just going to continue working on just the right-hand side for the rest of this problem. Okay, so I'm going to leave this alone, 1 over cosine 2 theta. And then over here, I have the 1 over cosine squared on top. The bottom one, I'm going to combine that together by getting common denominators. So the first fraction I'm going to have to multiply by cosine squared over cosine squared. And that way I can get the same denominator as the other one. I don't have to multiply the second fraction because it already has the common denominator I'm going for. So just doing that by multiplying top and bottom by cosines. Okay. Now once I get done with this, I'm going to do, so this side I'm still going to keep the same. And then what's going to happen is I get 1 over cosine squared on top. On the bottom I get 2 cosine squared theta minus 1, and that's going to be over cosine squared. So I'm putting those together. These two fractions I put together for a single denominator, and I got that. Okay. Now I'm going to continue the problem over here on this side. So this problem goes down here and it'll continue over here. Still, I'm not doing anything with the left-hand side. The right-hand side, I need to flip and multiply the two fractions. So I have 1 over cosine squared. When you divide a fraction, you're multiplying, taking the top fraction, multiplying it by the reciprocal of the bottom one. So I'm going to multiply by the reciprocal. This is going to be cosine squared I have on top. On the bottom I have 2 cosine squared theta minus 1. So I flip and multiply. It's going to look like this going from here to here because I want to get this to be one fraction. And by doing that, that allows me to cancel out the cosine squares. So now I have 1 over cosine 2 theta is an equal 1 over 2 cosine squared theta minus 1. And the very last thing I do is I notice that 2 cosine squared minus 1 is one of my identities for cosine 2 theta. So I can just replace all, it doesn't matter which side, I can change this into 2 cosine squared minus 1, or I can change out the right hand side. What I'll do is I'll just change out the right hand side. So since I know 2 cosine squared minus 1 is an identity, I can just go ahead and put that over here. And that way I get both sides equal. So your problem is really all this, starting from here, going down, and then continuing down here. That would all be one problem, showing how both sides are equal. So now, once you get down to here, again, it doesn't matter if you have the 2 cosine squared or the cosine 2 theta, as long as both sides are equal, that's enough.